Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Pharmaceutics MCQs made simple. Today we are going to discuss about packaging of pharmaceuticals part 2, glass containers. Prepare, practice, succeed. So under the packaging of pharmaceuticals, so already we have discussed about part 1, packing of pharmaceuticals. So today we are going to discuss about packing materials used for for making containers. First is the glass. Part 2 today we are going to discuss. So glass containers. First, composition of pharmaceutical glass. So component of glass containers are silica, soda, lime, alumina, boron oxide. So these are the percentage of the each component. And the functions of the component silica function is producing strength and chemical resistance, soda producing lower melting point, lime producing stability for the containers, alumina provide improves durability, and boron oxide is producing thermal and chemical resistant containers. Glass is composed of sand, soda ash, limestone and cullets. So this cullet is broken glass that is mixed with batch and act as a fusion agent. It's very important. So cullet is act as a fusion agent for entire mixture. The composition of glass varies and depends on the specific purpose for which it is used. Move into the questions. Which component of glass is mainly responsible for chemical resistance and strength? So option C, silica. So silica nearly 70 to 75% is present in each containers, forms a glass network and provides strength and chemical resistance. Function of cullet in glass manufacturing is option C, act as a fusion agent and reduce melting temperatures. And it melt easily and helps batch fuse uniformly and saving energy. Which component is added to glass mainly to lower the melting point? So option B, soda. So soda acts as a reflex, reduce the higher melting point of silica. Boron oxide is mainly present in which type of pharmaceutical glass? So option C, boron silicate glass. So boron oxide impact thermal shock and chemical resistance. So characteristic of borosilicate, it is type 1 glass. Which component improves the durability and hardness of pharmaceutical glass? So option C, alumina. So nearly 1 to 3% of alumina is present. It increases the mechanical strength, durability and resistance to devitrification. So next, types of glass containers. So first is the soda lime glass. So in soda lime glass, it containing silicon and lime and CaO with the trace of K2MgO and aluminum trioxide. It's a properties of this soda lime glass are easily manufactured, inexpensive, liberates alkali in aqueous preparations, lose brilliance on repeated use, and poor resistant to sudden temperature changes, and flakes separate easily. It is very important. So in which type of glass are flakes separate easily means lime soda glass. And it is used for a container meant for solid medicament, not suitable for parenteral. Second one is borosilicate glass. It's containing SiO2 It's a B2O3, Al2O3 and Na2O plus CaO and other oxide 2%. Its properties are chemically more inert than lime soda glass. It's a highly resistant glass. It's used where high chemical resistance is required. And third type is silicon treated glass. So glass treated with a silicon coating, and then lime soda glass is treated with silicon coating. So prevent interaction with content and suitable for alkali sensitive product. So it is used for storing alkali sensitive pharmaceutical products. So fourth type is sulfured glass. So sulfured glass, soda lime glass exposed to moist sulfur dioxide at 500 degrees Celsius. So it's very cheaper variety and does not liberate alkali. It's used for parenteral product containers. And fifth one is neutral glass. So these are all the composition of the neutral glass. And its main properties of this neutral glass is resistant to alkali and weather, can withstand autoclave. It is used for multi-dose vials, transfusion bottles and ampoules. Last one is amber color glass. So obtained by adding carbon, sulfur or iron or magnesium dioxide. Its properties is filtered UV radiation and protects from light. So used for photosensitive pharmaceutical products. Moving to the questions. Which glass liberates alkali into aqueous preparations? So option C, lime soda glass. So lime soda glass poor chemical resistant and release alkali, making it unsuitable for parenterals. Soda lime glass containers are mainly used for, so option C, solid medicaments. So due to alkali leaching and poor thermal resistance, soda lime glass is used only for solid products. The presence of boron oxide in glass mainly improves, so option C, thermal and chemical resistance. So boron oxide is the key component of borosilicate glass, so enhancing chemicals inertness and heat resistance. Which glass is mostly chemically inert? So option D, borosilicate glass. So silicon oxide and boron oxide content makes borosilicate glass highly resistant to chemical attack. Silicon treated glass is prepared for storing, so option B, alkali sensitive products. So silicon coating prevents interaction between glass and content and protects alkali sensitive drugs. Sulfured glass is prepared by treating soda lime glass with, so option C, moist sulfur dioxide at above 500 degrees Celsius. Which glass is cheaper but suitable for parenteral containers? Option C, sulfured glass. Sulfured glass does not liberate alkali and is lowest cost alternative for parenterals. Which type of glass can withstand autoclaving? So option B, neutral glass. So neutral glass has high resistance to alkalis and weathering and can tolerate steam sterilization. Neutral glass is commonly used for, option C, multi-dose vial and ampoules. Amber colored glass protects pharmaceutical products by, option C, filtering ultraviolet radiations, say amber glass UV rays, preventing photodegradation of sensitive drugs. Amber color glass is obtained by adding, so option B, carbon, sulfur, iron and magnesium oxide. Which glass shows poor resistance to sudden temperature changes? So option C, lime soda glass. Lime soda glass has low thermal shock resistance and easily cracks with rapid temperature variation. So next is the type of glass used for the parenteral preparation. So there are three types: type 1 glass, type 2 glass, type 3 glass. So first is the type 1 3 glass. It is the type of borosilicate glass or neutral glass. It is high hydrolytic resistant due to chemical composition, and no surface treatments are required. And it is uses suitable for all parenteral preparations including aqueous solutions and buffer and unbuffered solutions. So for the testing of purities done, name of the test purities done, its name is sulfured glass test. So powdered glass test to be done to check the purity of type 1 glass. So name of the test is powdered glass test. And next is type 2 glass, treated soda lime silicate glass, high hydrolytic resistant. It is treated surface treated with ammonium sulfate or sulfur dioxide, and it is mainly suitable for buffered solution and most acidic and neutral pH below 7 solutions and aqueous parenteral preparations, dry powders and oleogenous solution. So make note, type 2 glass mainly used for aqueous parenteral, dry powder and oleogenous solution. So test to be done is a water attack test. It is also called as hydrolytic test, hydrolytic resistant test. Another name for water attack test is called hydrolytic resistant test. And type 3 glass, soda lime silicate glass. It is moderate hydrolytic resistant. So no treatments for this type 3 glass. It is suitable for non-aqueous parenteral and preparations and powders for parenterals, and except freeze dried product, it can be used for all the powder parenteral packing. Not suitable for aqueous parenteral, dry powder or oleogenous solution. So test to be done, powdered glass test. So type 1 and type 3 required the powdered glass test, and type 2 is required water attack test, also called as hydrolytic resistant test. Type 1 pharmaceutical glass is also known as option C, borosilicate glass. So type 1 glass is borosilicate glass with high inherent hydrolytic resistance due to its composition. Which type of glass does not require any surface treatment to achieve high hydrolytic resistance? So option C, type 1. So type 1 glass naturally has high hydrolytic resistance, so no surface treatment is needed. Type 2 glass achieves high hydrolytic resistance mainly due to option C, surface treatment with ammonium sulfate or sulfur dioxide. Type 2 glass is most suitable for, so option B, aqueous parenteral with pH below 7. The official test used for type 2 glass is, so option C, water attack test. So type 2 glass is elevated by water attack test, so also called as surface hydrolytic resistant test. Which type of glass shows moderate hydrolytic resistance? So option C, type 3 glass. Type 3 glass is not suitable for option D, aqueous parenteral preparations. So due to moderate hydrolytic resistance, type 3 glass cannot be used for aqueous injectables. Which glass type is tested using powdered glass test? So option C, type 1 and type 2 is required powdered glass test. So next is quality control test for glass container. So chemical test, so hydrolytic test, and in order to check the hydrolytic resistant test, first is a powdered glass test and water attack test. So powdered glass test is done, measure the alkali releases from crushed glass. Water attack test is measures alkali leaching from inner surface. So powdered glass test done for type 1 and type 3 glass for non-parental. Water attack test done for type 2 glass. And hydrolytic resistant of glass grains powdered glass test. The titration with decant solution with 0.02N sulfuric acid using methyl red indicator. And hydrolytic resistance of surface is the water attack test is fill it by 90% capacity of water and autoclave 121 degrees Celsius for 30 minutes and titrate the decant solution with 0.0N H2SO4 using methyl red as an indicator. So here titrant is used 0.02N normality of H2SO4. So type 1 1.1, type 3 8.5 and other non-parental 15. So butyriline. So next is the test for hydrolytic resistant glass. Glass containers should be compiled with the test for hydrolytic resistant as given in IP. The test is carried out on the unused container. The number of containers to be examined and the volume of test solution to be used are given in. So 5 ml or less, at least 10 containers to be used. So minimum 50 ml of the solutions are used and more than 5 ml up to 30 ml at least 5 containers and 50 ml of the titrant solutions are used. More than 30 ml of 30 ml capacity, so at least 3 containers and 100 ml of the solutions are used. The test for hydrolytic resistance of glass containers as per IP is carried out on option C, unused containers. For the containers having a normal capacity of 5 ml or less, the minimum number of containers required for hydrolytic resistant testing is, so option D, 10. So it is less than 5 means it's at least required 10 containers as per IP guidelines. Which test measures alkali release from crushed glass? So option C, powdered glass test. The powdered glass test is applicable for which type of glass? So option D answer, type 1 and type 3. In the powdered glass test, the decant solution is titrated using, so option B answer, 0.02N sulfuric acid with methyl red as the indicator. Maximum permissible volume of 0.02N H2SO4 for type 1 glass in powdered glass test is option B, 1 ml. So type 1 glass has highest hydrolytic resistance, hence lowest acidic consumption. The water attack test elevates. Option C answer, surface hydrolytic resistant. During the water attack test, glass containers filled to 90% capacity or autoclaved at option C 101 degrees Celsius for 30 minutes. Type 2 glass containers differ from type 3 glass container because type 2 glass is, so answer in the comment box. So join in our WhatsApp community. You will get hands-out material. Thank you. Like, subscribe and share.